Yeah, let's get to it.
Hello, everybody. Welcome to this talk. Andrew Hewus Fresh is going to be talking about HealthCheck Diagnostic Results for your code. Andrew?
Howdy, everybody. I'm Andrew. I wanted Brandon Messinio to give this talk, but as he's been doing a lot more of the implementation side of everything and writing stuff and actually using it. He was busy though and decided he didn't want to, so you get to hear from me instead. So I'm going to start with a little story about growing pains. So we started out, happily providing services to people with a monolithic app, and it probably needs file system access, and it's pretty simple overall. Eventually you add a database to it, and it's still pretty easy to monitor. When something breaks, there's not that many things that can go wrong with your application because there aren't that many pieces to it. So figuring out what's wrong is pretty simple. But then you look over and you see somebody else has sprung up another app on you. And somebody else has some other services running on a different monolith that's got all these same requirements. And then there's, a few more and lots, and you end up with a whole bunch of these things just running all over the place. Now, our ops team's pretty good, and they were able to get everybody working on the same page mostly, and everything's kind of in the same, all automated and working the same way. And so everything's kind of all in the line and working. So now everything's pretty easy to keep track of and work on, and life's pretty good. Of course, then you realize that these two monoliths are sharing this piece of functionality, and these four monoliths over here share a different piece of functionality, and these three have a different thing that's re-implemented in each one and by a different team of people. And then the folks that are using multiple different of your applications are really confused when they update stuff in one spot and it doesn't get actually migrated and update in all the other places. And so they have to update things over here in all these different places. And, one answer to that, and the one that we went with, is that we chose to break all these things out into microservices, and so that the apps could talk to each other. And, some of the functionality, of course, will remain in the specific monolith, and you just talk to an API that's there on the monolith itself. But wherever it is, we finally start, each of these apps talking to each other, which suddenly makes everything much more difficult when something talks to this app, and then these microservices talk to that microservice, or these monoliths are talking to this microservice, and more things are talking to each other. And everything is just getting really complicated. At least you realize that this monolith got completely replaced with, a couple of microservices, and that's the part you put in the report to your boss and say, look how much simpler we're making everything. We're getting rid of services, or getting rid of stuff. But of course, then you don't mention that, now you've got more microservices showing up doing more things, and all of your monoliths are starting to talk to those. And of course, the microservices then talk to each other, and there's just so much complexity. At this point, even the people who are managing this stuff don't know what depends on what, and what things need this and what needs that, and who needs what, and access is who knows. And this, of course, doesn't even get into talking to external APIs that you're almost certainly talking to and that require different access. And of course, all of these services and monoliths and everything are redundant and running in different data centers on different host stacks, and all of this in different pieces that are deployed in different places. And the security folks want to know how they can tighten up the firewall rules. So they want to know what features you actually need and who you need to talk to. And then you hire somebody new, and you try and explain to them how to troubleshoot something. Somebody asks, is everything okay? Well, automated tests can make sure that each piece of code is functional before you deploy it, and integration testing, make sure that the APIs remain compatible. So when you talk to each other, so the different things talking to each other probably should work. But if you have a failure in microservice, it could lead to a cascade of failures across multiple different microservices and monoliths everywhere. So how do you know if the running systems are fine, are okay? And if not, how do you find out what actually has failed? What pieces failed? Well, about this time, I saw Kelsey Hightower talking about Kubernetes and Google's Healthy Endpoint. And I was like, this is it. This is the solution we need, because we were looking at migrating some stuff to Kubernetes at the time and whatnot. And so I quickly went to the cPan, installed the modules, and that was it. That was the docket. Glad you were here. Oh, wait, that's not it. There wasn't anything on the cPan. I was like, wait, what? How can that be? How can the cPan not have a framework for doing this? It's not a problem that's unique to us at Grant Street. So it's like, okay, well, what are other people outside of the Perl community doing? Somebody there must be doing something good. And the Financial Times has a pretty good write-up about what they did and the standard that they use for their apps to communicate. And so it had some really good ideas. But strangely, that was really the only thing I saw that people were using to talk between, or to monitor their different applications like this. And to do that monitoring from the inside and seeing, what the app is doing from the inside. So I saw a recent blog post the other day from Perl Dean talking about Stack Overflow stuff, but he was mentioning that Perl doesn't have something for real good observability of what the app is doing and whether it's okay or not. And I know that that's something that we're missing, but I don't think it's that. We don't just have it. I couldn't find anything from anybody else either. So this led to lots of thinking about what a good solution might look like. Something that would work for all of our services. Most of ours are Perl, but not all of them. And what would make it easy to monitor not the new things that we build, but that was flexible enough, not just to be a yes, no, but that would also tell us what was wrong when something was wrong. This led to writing up a HealthCheck standard. It's public on our github.io site. And it's pretty simple and kind of based on the Financial Times version, but a little bit more flexible and hopefully can be extended to do a little more than that. And there's more examples of this in the standard, but here in all this mess, the only required field is the status, the second line there, which follows the Nagios convention of okay, warning, critical, and unknown. And of course, that's not actually a hard requirement, because if you don't provide it or if it doesn't match one of those, we can treat it as unknown. Here, the ID field is highly recommended because it's used internally to uniquely identify things, and will probably be making it externally more visible and returned in the result by default, the generated one, as I need to use it for some stuff. So this defaults to the index into the list. So if you look at the very bottom result there that says it failed to do the right thing, then that actual full ID is my_app dash simple or aggregate underscore check dash 1, because that one doesn't have an ID. So in this, the label there is the human readable version of that ID. And the info field is the human readable version of the status, the reason why it is. The timestamp we haven't been using too much, but it's the when the check was generated, which is usually right now. So we usually just assume it's right now and don't actually put it in. But here's the piece that's really the thing that the Financial Times one was missing, is that the results are a list of additional results. So it's completely you can continue to add additional details as far down as you want. And then of course, tags at the end are ways of grouping things together. And generally, I'll show you how they work a little, or how we've been using them a little later. And generally we use the same results on the check side as on the result side, but that's not actually necessary. And so maybe there's a reason to do it different. This of course turned into a Perl module so that we could do stuff and that lets you register diagnostics and run the checks and return the results. And it's a fairly simple, pure Perl module currently, I think, with no non-core dependencies. Some people have been trying to talk me into log any for it, but we'll see how that goes. And I started adding it to a few apps to see how that would go. And I know that you're thinking, or you're probably thinking, this sounds really complicated if you want to actually get anything useful out of it. But fortunately, that complicated stuff is tying those results to the things in your application that you're the expert on. I mean, this is a perfectly valid diagnostic. It isn't really useful for anything but being readable from the back of the room, which is not especially useful for an online conference, but any additions to that, choosing what that status should be, are based on your app's code and what your app does and what you're an expert in. So here's an example of using that health check where you instantiate a new checker, and the health checker is really just groups the diagnostics together. And you can register them either when it starts, where you'll see that there's mostly that very simple one with just an ID added to it. Or you can register them after the fact as a whole module that does the diagnostic interface. And it turns out that the main health check itself is actually supports the diagnostic interface API. And so you can register a health check with itself, which allows you to do subgroupings of different checks to group them together, so it makes looking at them and reading them a little easier. Doesn't have any loop protection currently, so if you register it with itself, it's going to get into an infinite loop and just keep going and not give you any results, so I wouldn't recommend it. Anyway, this is where tags really shine, because you can choose to only run a specific subset of tasks that you want to, or subset of diagnostics. Then, so for example, if your service provides a really important feature and it doesn't rely on like a lot of the more it relies on fewer of the things that your entire application relies on, but that particular thing would work. Maybe you have some checks that specifically linked or specifically check that one service is going to be working, and it wakes people up if that one fails. So in order to make it easier to share that simple subroutine, the HealthCheck module comes with its parent class, HealthCheck Diagnostic. And this provides some niceties like wrapping the check that you write in an exception handler so that it can provide a critical response and some info about the exception right there in the results that you're already monitoring, rather than relying on exception handling to maybe do that for you. Plus, it does some validation and summarization of that result that it got. Although most of the validations are only warnings because, like I said, lots of the things are pretty flexible in what they are allowed to return. So you do need to just watch your logs and stuff for those. So here's an example of pretty much that simplest callback, just wrapped in the HealthCheck Diagnostic parent module. And you can see how simple it is because I can make this font pretty big and include the true value at the end even. So we've talked about some other helpers and stuff that might get added to this, but it turns out that it's really functional enough the way it is, and nothing else has been necessary, just a few things that might be nice. So let's go try out a real quick live demo if we can, because that's super fun. So hopefully you're now seeing the sample super simple plaque app I've got going on here. And it doesn't do anything except say hello world, which is great. And we can try browsing over here to the HealthZ endpoint. And yeah, it doesn't actually do anything because there isn't one. So let's see if we can add a health check to that. Ooh. Okay. So here we add a health check, and that's super simple one that I showed before pretty much. And of course, it still doesn't do anything because we haven't tied it into our plaque application here. So let's go over here and tie it to the plaque application. And that's just enabling the middleware that's available and telling it to use the health check that we've instantiated here. And now when we reload, we get some JSON output for that result. And of course, we probably want a little more useful diagnostics than that. So let's create our own useful, terribly unuseful diagnostic that really just picks a random status to give us. And here we register it as a class method, just as the class. The nice thing about registering it as a class here is that there's just strings being involved. So you can register it that way in like a YAML config file or something. And so have your health checks defined in a config file somewhere rather than having to do it in your code and just load in that YAML. Anyway, so here now we see our nice random result, but that's not actually very nice to look at. So let's tell it that we want it to be pretty, and we'll get some actually useful JSON output that we can more easily read and see how it is. So now we can see that we're getting our random results, and the main status defaults here for the worst case or the worst status of all of the subchecks that it sees. So you can also add, instance version of that same check. And that also gives us different random results. And here's where we can try out some tags, because now we can say tags equals random, and then we just get back that one random check that we were looking at before. But we can also say tags are not random, and that'll give us everything but all the checks that are the diagnostics that are not random, which is pretty useful. And you can combine multiple tags, both positive and negative, to get usually get exactly the subset that you want. So let's get rid of that extra random one and keep this tag in here so we can go back to this more reliable result here. Let's see what else we can add. Let's add in a file permission check. So here we've got our app.psgi, and that's a web app here, this very simple web app that we're running, and we want to be able to have the web service read and execute it, but we don't want the web service to be able to write to it because, well, we don't want just any random bug in our code to let people rewrite our app. So let's see what happens here. And oh right, I guess I'm running the web servers myself, so I really do need that. So we'll just mark that as a to-do to make that not writable. So now we've got the correct permissions. So next up, what can we add here? Oh, let's add in a database connection, because that was the other thing that our app was using, is database connections. And here we're just using SQLite, but really it's just any sort of callback that returns a DBI handle. And as long as your database handle can ping, we can get a successful result from it. And so then maybe we want to check the permissions on the database file. And really you can check different permissions and everything. And here we can say that we want to read, write, but not execute the file. We've got all sorts of other permissions that you can choose. It can check for ownership and actual file permissions and stuff. I don't think it currently does ACLs, but maybe we can do that. And of course, if you want to do more than just ping the database, we actually can have a check that can check whether you have read access to it or write access to it. Not 100% sure how that actually works, but because I didn't write that one, but supposedly it checks how you're connected and what you're connected to and whether you can do stuff. So last thing on the demo is something just fun. We're going to change the name of the paths that we use to be a handy Unicode thing. And as we see here, we change the path that it's looking on. And now we get back to the hello world because it's no longer the health endpoint. And now if I can copy that, because it's Unicode and I don't know how to type that, prescription doohickey, but we can access the HealthCheck endpoint from there. You can actually have multiple HealthCheck endpoints, and if you want, if you're like migrating from one to another, you can enable both of them, and who knows, whatever. So that was a super fun app, and we've got all of these different checks, and we can use tags to sort them out and add them in, and that's, you know, actually pretty simple. So what good is this to you? Well, I knew I wanted to open source this pretty much once I figured out there wasn't anything on the CPAN. And it was one of the driving factors behind all the work that went into my conference talk at the Perl conference last year. This was kind of, you know, being built at that time, and I knew I wanted it to come out. So all this stuff, including a handful of diagnostics for that DBH ping, DBH check and stuff, but also for a Redis check, and one that will make a web request and make sure it comes back as whatever status you want, and maybe has whatever content you want on it, and several other things are available on the Meta CPAN. Just search for the HealthChek Diagnostic, and they should all come up hopefully. But in addition to all of the documentation that's in that main diagnostic module for writing your own, the list does include a getting started guide for writing your own diagnostics and kind of best practices that we've come up with. And if anything is unclear, bugs and limitations in the docs are great things to file issues or PRs on GitHub for. So now, what good was all this? Was all this thinking and spec writing and making code that did what I want worth it? So far, yeah, really, it's been really, really nice. We've got default health checks that, along with some of the stuff I talked about last year, are part of the boilerplate that we have for our new apps. So when you spin up a new app, it has a whole bunch of things automatically built in. And some of the key benefits I talked to Mark Flixinger about. Mark keeps all of our automation stuff working, and he just is the person when something's broken, you say, what to help me fix it. So he was really helpful in telling me, what exactly are we using these for? And so one of the things that we do that with, what we do is we know almost immediately whether maintenance broke something. And because we have this tied into Nagios checks, but really you can make anything because it's just returning JSON. But we have Nagios checks that are now significantly more reliable than the checks that we had before, because they're actually asking the running app itself what it thinks the status is, rather than maybe spinning up a process, next to the app on the same machine and trying to make that connection. It actually looks from inside the app to make sure stuff is working. We also use it as a part of our post-deployment checks, so that it makes sure that when the stuff comes up, it brings in it makes sure that all of the health checks pass before it connects in the new code and brings down the old code. And since it's so easy and used for so many things, we have lots and lots of more tiny little diagnostics that get added to this that wouldn't be if it were just in Nagios somewhere and that was the only thing using it. But because we can go look at it manually, or have a check that have some tool that goes and looks directly in it, or directly at a specific tag for something, we use quite a few different diagnostics in it. And lots of those are just there, like I said, when you spin up a new app, or if you add a new connection to a new service that we're using already. We've probably got a diagnostic built already for our own for whatever that service is, so that you just add both the new service module and the diagnostic module, and then easily get not only access to that service, but monitoring that it's working. Now, all the work to get it open sourced, is that worth it? Well, we'll find out if I get to use a diagnostic that somebody other than GSG puts on the CPAN. So, like I said, one of the main benefits is that as we are now moving a lot of stuff to Kubernetes, we're able to use the HealthCheck as a liveness or readiness probe. And that means that we only have to implement that once and get lots of benefit out of it. But more than just that Kubernetes basics of it wanting a 503 status if it's not working, and a 200 if it's okay. We also get that JSON encoded result back on the checks that were run. And we do that in that FLAC middleware that's on the CPAN. And it passes along any tags, like I said, so you can choose exactly what checks to run. And along with that pretty parameter, it makes it human readable. And that means that all of our web services, no matter whether they're in Perl or not, have a dedicated URL that you can go visit and see whether it's working, and if not, what's broken. So if I'm filling in and helping support an app that I'm not super comfortable with, I can quickly go and see if something failed and what it was, and be able to hopefully at least make faster progress on it and ask the right people the right questions. But I did lie a little bit there, and we actually subclass that middleware that's on the CPAN, and it adds another endpoint that uses a hard-coded tag to run a subset of checks, and it doesn't actually return a full result, just okay, or I don't remember what the other result is, but it's not okay. And because it runs this really small subset, we can run it really frequently, and it's just the really important things that means our app at least will show something to the user or to the person who's browsing the site, whether or not everything is functional. And that lets us poll it much more frequently and be much more responsive. And this check used to be to do just really super basic things, but the flexibility of powering that via this health check, that means we can add additional really important things to that check as we need them, and find out things that are fast to check, but affect reliability a lot. And I mostly here focused on showing off that web interface or the JSON interface, but there's nothing in the spec that says that's the way that you have to use it. You could easily have a command line tool that dumps out the result, or maybe you exec it from inside a container and maybe you have a result that you send via a message queue of some sort on a schedule, and then something collects those and alerts if it doesn't get them or if they're bad or something like that. So the idea is that it's just super flexible, and hopefully you can do a lot with it, and it'll fit into your apps and the way you monitor things, even if that's not the way we do it. So we do have a team that's has a Go implementation. I don't know much about that because I haven't really done anything with it, but it returns a HealthCheck result on that standard URL that I can go check if I need to. I believe that we wrapped something around some of our Java apps that returns a health check. I'm not sure how they did that, but it still doesn't quite introspect into the Java thing because it's like, I don't remember, Jenkins and stuff that were just apps that were running, but it's wrapped around it and provides that same information. But here are monitoring tools, and the people that are doing the monitoring don't have to know whether it's an app that's written in Perl or not. They can just go to this place and see whether it's working. We've got another team that's doing a bunch of stuff in Monoliths, and they're thinking of replacing the Plaque middleware with the Monoliths plugin because it's going to make Mojo better to not use Plaque and use something else. I'm not sure, but lots of different options available because it is wrapped around this kind of standard API. And hopefully now you're all waiting to tell me, that's amazing, I've already installed it, it's in my app already. I'm looking at the health of my app on over the VPN and seeing what it's doing right now. But what are the cool things you're working on the future? Well, for one, we have a pull request that's internal that hasn't made it out to the CPAN yet, that's adding runtime support. So you can add a flag to the, pass in asking for runtime, and it'll tell you how long each of those results took to generate so that you can help diagnose, because one of the problems is we've gotten so many is that it takes a really long time to run this, and we want to sort this down a little bit tighter. Of course, that's with the Nagios integration, having that Nagios check that endpoint and using tags to split up into multiple checks is great, but it's also a lot of work now that we've got a whole bunch of checks. And of course, a single Nagios check only gets a single downtime setting and one contact setting, so just putting it all into one is not ideal. So I'm working now on a thing that will generate passive Nagios objects for the services from the output of a health check, and then submit the passive results back in with an actual active check. It's still in progress. I don't know if it's something I'll be able to make generic enough to open source, but maybe could be useful. But that means that the contacts and the downtime and whatever else can be separated out into a very specific, or into what level of detail and who needs to get the result or the status message, or if it's just something that you want to, that nobody actually needs to be woken up about, but you want to know if something goes wrong. And really the point is that this standard result is a really powerful way to build a thing for building on top of. And it's not just for alerting, but for other sort of dashboards and things. Although we haven't gotten too far with any of those sorts of dashboards yet, but I hope that we will get there. Some of the other things that we're hoping to do with it is be able to deactivate app features because the health check has failed. So for example, we might verify connectivity to the credit card processor with a health check and disable the checkout button and show a more helpful message to the user than letting them try and click it and whatever. Maybe we have a cron job that can make sure that all of the resources that it's going to need to complete its run are at least available at the start before it gets to the end and fails. And we haven't currently started collecting any metrics from this. Not sure exactly what we're going to want to collect. And I watched that open tracing talk a couple of talks ago, and that might be the way to go. But some results might be good to come back here and do that. And it would be nice to have at least some sort of metrics coming back. So I think, let's see, I'm way ahead of time. So anybody have questions and stuff that I can answer before, or I guess raise your hand and somebody will let you unmute or something, or I don't know.
What are you using to collect the health checks?
Currently, it's all in Nagios. That's the main thing that we're replacing our Nagios checks with it primarily right now. But we do also use it a lot just to go hit the website or hit the endpoint and look at it and see what's working and not working. And of course, Nagios integrates into PagerDuty, which sends us the thing that actually, that pops up into Slack that says, here's the thing that's broken, which hopefully will be a little clearer once I get all of the checks all split up. But sometimes it says something's broken, and then we have to hit the endpoint to find out what it is, because it gets a little confused sometimes. But I'm hoping for a dashboard of some sort that has all of our different apps on it that you can look at it in one place, and will update and show green or red with a little a better indicator of what's going on. Just haven't gotten to that yet. Yeah, I've been
Chat.
Yeah, I see the question about OpenBSD on there, and so yeah, I've been had an OpenBSD account for several years now, and I keep Perl up to date in the OpenBSD or in the base system, because we still ship Perl with OpenBSD, and I haven't gotten 5.32 in there yet, but we're on 5.30 anyway. I really like it because it keeps itself simple. They are really good at saying no to features. So rather than just implementing whatever crazy new idea comes up and making things really, really complicated, they like to just hold off and make sure that it's something that's actually useful and whatever. But they are still always pushing forward on different other things that trying to improve security and whatever and make things better. But I mostly just like it because it seems to stay out of my way a lot better than any of the other operating systems I've tried, and generally has been very reliable. So I do want to mention some updates from last year's talk. We've continued to add the DBX class events to more things, which was what the talk was about, sort of. And I talked about moving to this new internal process that was a lot more like our open source process. And all of the modules, shared modules, the internal ones on our team, on the team I'm on, have moved to that new workflow. And I think we're pretty close to moving everything. And we're going to start moving our applications to a really similar to that workflow. And because everything is kind of the difference between somebody working on a open source project or working on a internal project is before it merges, you have to get 2 extra pieces of approval. And so, or 2 extra people to approve it, and that's it. So it's really a very low barrier to open sourcing things. So that's really nice. And like it says, we're up to 27 distributions on the CPAN. Most of them are, or many of them, not quite half, are up to are HealthCheck related. So anyway, let's see. I wanted to say thank you to Grant Street for making all of this possible, and letting me open source it, especially Brandon Messinio for doing all of the work that he's been doing to it, and everybody else that has been doing it. And Mark Flickinger for all the things he does, the TPF for all they do, the conference organizers for changing gears and putting on an excellent conference in the cloud. I've been really enjoying it so far. And all of the folks that are in the Perl community who are looking to the future and not stuck complaining about how it's not as good as the past. GSG is not currently hiring, but once we figure out this whole thing, I'm sure they will be again. So anyway, back to, we are? Ah, Doug says that we are hiring. Who knew?
Thank you, Andrew.
And I, where did all that go? Yeah. Yeah, look at that. I missed an announcement yesterday of the conference that we're hiring. So anyway, I will be happy to answer questions. Send me email, talk to me on Twitter, IRC, whatever. And let me know how it works if you're using it, and I'll appreciate it.
Does anybody have questions?
I don't know. Maybe someone walked down the hall. My wife just switched rooms. I have the door closed. Here, and they're with me.
Yeah, I've got several minutes more for questions. So,
are you looking at any performance metrics?
So, like I said, the only one that we have so far that's not actually that's still in a PR state is that we're looking at runtime statistics for how long each individual check takes to run. And I would like to add the ability to have the diagnostics return more performance metrics of some sort. I'm not entirely sure what those would be, but depending on the check, it might have something. And putting that into a standard format that then some other tool could access and log and turn into graphs and stuff would be nice. Though now, after seeing that open tracing talk just a minute ago, I don't know whether or not what I want to do, but And I mean, we do. Yeah, I mean, I guess it could definitely. There are some. I don't know if that DBH check thing does it, but I believe that it. There is one that maybe isn't open sourced yet, or I don't know. We are doing something that will be able to make a SQL query, do something, and base the check on the result. So being able to count like slow queries and stuff would be nice.
Okay, thank you for speaking. If anybody has any questions, Andrew, are you available in Slack for the questions, or?
I didn't join the Slack. You generally don't think Slack is a good thing unless you're paying me to be there. But I am on IRC and other places. So.
Okay, thank you for